Hi folks, I'm back for part 2 of your notes. We're going to talk about permutations and combinations, and then there's a little bit of practice at the end of this. That's kind of mixed practice. Your homework after you watch this video is just going to be some textbook homework, but it's pretty limited, so try all of them, but the last one especially, my hint is to list out the formula for it and then plug in what you know, and it actually comes out kind of cool. But if you have trouble with it, you can use my office hours to ask me specific questions. Also, I'm going to direct you on the graphing calculator, but if there's something you can't follow along with on your own, again, just chime into the office hours and I can literally just show you on the calculator what it should look like. All right, so a heads up, permutation is something that is a combination of elements where the order actually matters. Okay, so for an order mattering, that's called a permutation. So what's funny is when you guys open a locker, it's a lie. Lockers are technically locker permutations because the order of your code should matter. So instead of calling it a locker permutation, they call it a locker combination, which is wrong, but it has been adopted everywhere. So just so you know, if the order does matter on a permutation, just so you know, the easiest way to think about this without having to know a formula first is just to think about what would be your first letter, okay? So your first letter, you have how many options, right, if order matters? You have 6, right? But then, if the order matters, how many do you have for your second slot? Only 5, and so on. So it decreases because you've already used the other letters, okay? So what happens is this becomes 6 times 5 times 4 times 3 times 2 times 1, which ends up being 720. Now, a shortcut for this is something called a factorial, okay? So a factorial looks like a really excited 6. It's like 6, except it's not. It's 6 times all the numbers after it. There is a button in your graphing calculator if you want to see how it works, but the long way, which I'm going to have you show a little bit of work for in the future, is to actually just list out 6 times 5 times 4. Now, if you want to see the shortcut, if you go to math, probability, there's a bunch of buttons in there that we're going to use for this unit, but number 4 is the factorial button. So if you type 6 and then go to math, probability, number 4, that's factorial. There is a formula for a permutation, but if you wanted to figure out the number of elements in a permutation, you could just literally list out the factorials. This is representing n times n minus 1 is literally n factorial, so it's showing you that if I did 10 factorial, it's really 10 times 9 times 8, and so on, okay? All right, so to actually figure out the permutations of something happening over time, say you have to choose like 2 out of 6, so you chose 2 out of 6 of those numbers, it would look a little bit different because you have to divide out the total options that you're actually choosing from. So, for example, if you are having 8 horses running a race, we care about what place they go in. So it says they want a first place, second place, and third place. So what that means is you want to get every option for those people winning, right? So what you end up plugging in is your formula. So technically you could just do 8 times 7 times 6 to think about the places. Or you could say, I want 8 horses, but I'm only choosing 3 of them. That's a 3. To actually get prizes. So you would say it's 8 factorial if you plug in the formula. This is your number of options. Okay, options. This is how many you're choosing. So if we have 8 and we're choosing 3, that's 8p3. Okay, so you do 8 factorial over 8 minus 3 factorial. So you could either do this the shortcut way and say I have 8 places for the first place person, but then I only have 7 for the second place, and 6 for the third, or you can use the formula. So you end up doing 8 factorial over 5 factorial. Now, instead of plugging that into a calculator, there's a lot of these that are just going to cancel. So you can actually do 8 times 7 times 6 and so on, because you're multiplying by everything previous, over 5 times 4 times 3. And think about if you kept it going, It means that a lot of these numbers are going to cancel, because this is 5 times 4 times 3 times 2 times 1. This is 5 times 4. So you end up with the same thing. And if you multiply that in your calculator, you get 336 ways for 8 horses to win first, second, and third. So the difference with distinguishable permutations is that you have to divide out any duplicates. So these are actually kind of fun for some reason to me, but you might not think so. So if you wanted to figure out how many ways you could write the letters in banana, notice that there are, let's see, count them, 1, 2, 3, 4, 5, 6 letters. So 6 letters. But then there are some repeats. So if we were to list this out, you'd have to literally do 6 factorial. But then think of the letters that repeat. So A, for example, happens 3 times. So you divide out 3 factorial. But there's another letter that repeats, N. It happens twice, so 2 factorial. So again, if you're going to cancel it out, you don't need to do this in a calculator because a lot of things are going to cancel, because you have 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Technically, you don't even need to show the 1 because it's times 1 times 2 times 1, right? So think about the things that are going to cancel. This is literally 6. The 2 times 1 cancels, so you're left with 5 times 4 times 3, which ends up being 60. Okay, try the next one, which is how many ways can you write the letters in mitosis. Pause the video, come back, and I will have it done for you. All right, folks, hopefully you figured out there are 7 letters in mitosis. There are 2 repeats, but 2 letters that do this. So I repeats itself twice, and so does S. So that number on the bottom is really 4, right? Because 2 times 1 times 2 times 1. This is still 7 factorial. So in your calculator, if you want to do this out, you don't have to actually type out 7 times 6 times 5. Try the factorial button now, and then divide by 4, and you should get 1260. Now, if you're curious as to see like why this works, it's literally every combination of letters. I'm saying combination, but it's really permutation. Just to think about like the order of the letters. So this is already one option, right? You can write the word mitosis out, but then you can do IMTOSIS. That's a second, and then you can move the N back to the front, but then switch the I with another letter, and so on. So distinguishable permutations just means like you can't have any of the same ways of writing the letters out. So banana would be a little bit easier to see. If you want to see it listed out, literally your textbook does that for you. We are not going to do that though. The other thing I want to remind you of is you can use the permutation and combination formula in your calculator. But for now, I want you to list out the formula so you can see how the things cancel. Sometimes it's easier just to cancel things out in your head. So the last one we're learning about is a combination. So just a reminder that with a combination, order does not matter. So that's why it's a lie when they call a locker a combination. Because order does matter with a locker, okay? Notice this is still N items that you're choosing, and whatever you're choosing out of that is R. Notice it's really similar to the permutation formula, but we have an extra R factorial in there. So we're going to start with letter A. Letter B they did for you. Actually, they did it out, which is kind of nice, but letter A. And how many different ways can 3 letters be chosen from the letters A, B, C, D, and E? The order of the letters are not important. So this would be a combination because we don't care about the order. So think about how many letters we have. So that's 5. We're choosing the order of 3 of them that we that we actually care about. So if we're plugging it into our formula, it would be 5 factorial over 5 minus 3 factorial times 3 factorial again. That 3 factorial is still in the denominator. So what ends up happening is more things cancel because you don't care about the order mattering, so it takes out a whole group of values that you don't care. Like, so A, B, and B, C, or A, B, and B, A are like the same to it. So it takes out a whole grouping of combinations. So this is over 2 factorial times 3 factorial. And if you were to list it out, that's 5 times 4 times 3 times 2. Sorry, this is not showing up. Times 1 over 2 times 1, which is 2, times 3 times 2 times 1. So what happens is you get the 2 and the 1 to cancel. A 3 cancels. You can say 2 goes into 4 2 times. So what ends up happening is you get a much smaller answer, which is 10. Okay, so there's actually only 10 ways to make 3 letters happen. And again, it's because the order doesn't matter, so it's a little bit lower. They do the same thing with the next question with poker. They're having you choose 5 cards out of 52. If you would like to try this in your calculator, you're going to literally type the number 5. Okay, go to math. Scroll over to probability. And you can jump to 3, which is NCR. If you wanted to do a permutation, you could choose 2, which is NPR. So choose 3 for NCR, and then type the number 3, because we want to choose out of 5, 3 letters. Hit enter, and it gives you 10. So for now, I want you to use the formula, but you're going to be able to use the calculator to kind of verify your answer. This is just a recap of the 3 things we learned over the past 2 days. If you want to check it out. Order matters, permutation, order doesn't matter, combination. 2 separate or 2 or more separate events is the fundamental counting principle. So on the next page, it's going to be a bunch of practice. I want you to try them out, and then I will just give you all the answers at the end. If you have questions, feel free to check in with me during my office hours. So try these 4 out. I'll zoom in for you if you can't see them because some of us don't have the paper easily accessible. So you can just try them on paper, pause the video for me, and I will reveal the answers. All right, folks, so your answers are officially up. So for number 1, you have 4 choices for amplifiers, 10 choices for stereo, and 5 for speakers, so you end up with 200 ways. Number 2, you get 4,000 for A, 5,000 for B. Again, your leading digit can't be 0. And the number must be even, which that part is a little tricky, but when you have an even number, the last number has to be even. So that's why the last number, you only have half of the digits you're allowed. For number 3, hopefully that one makes sense, 175,760,000. And then number 4, A is 40,320, B is 720. So all of these ended up being fundamental counting principles. Combination and permutation you will have a little practice for in your homework. So try it out. Let me know if you have questions during my office hours, or feel free to email me. Have a great rest of your day.